Here we have a non-elementary integral that can be used to find the period of a pendulum. This integral is called an elliptic integral of the first kind. Let's look at a problem involving the period of a pendulum. We are given that the period is equal to 4 times the square root of L over G times the integral from 0 to pi over 2 of 1 over the square root of 1 minus k squared sine squared of theta d theta. We can use the binomial series 1 over the square root of x equals 1 plus the sum from 1 to infinity of negative 1 to the n over n factorial times 1 times 3 times 5 and so on up to 2n minus 1 over 2 to the n all times x to the n. By comparing the integrand to 1 over the square root of 1 plus x, we can use this binomial series to estimate the integral. Notice that if we set x equal to negative k squared sine squared of theta, we can rewrite the integrand using the binomial series. So, substituting negative k squared sine squared of theta for x, we get the integral from 0 to pi over 2 of 1 plus 1/2 k squared sine squared of theta plus 3/4 k to the 4th sine to the 4th of theta plus 15 over 48k to the 6th sine to the 6th of theta and so on, with respect to theta. Integrating, evaluating, and simplifying, we get 1 over 128 pi times the square root of L over G times 25k to the 6th plus 72k to the 4th plus 64k squared plus 256. So, if we know the maximum angle that the pendulum reaches, we can substitute sine of theta over 2 for k into this expression and get a pretty good estimate of the period of the pendulum.